Hello, I am Sushma from Sri Venkateswara College of Engineering and Technology. I have done a project in emertxe on washing machine. Let's see the table of contents. A table of content contains introduction, embedded systems and its components, software used, PIC microcontroller, embedded C, peripheral description, project demonstration, and sample outputs. Let's see the introduction to the washing machine. Washing machines are used to reduce human labor and save the time. Washing machines have an important place in the modern society. Nowadays, we can see various kinds of washing machines. Customers want to have fully automatic machines instead of semi automatics. In this project, we have built a simple washing prototype using PIC 16F577A microcontroller. Daily we are seeing a washing machine in our households, so it plays a very crucial role in our daily lives. Let's see what is meant by embedded systems. Embedded systems is a combination of both hardware and software electronic gadget to do a specific task. Examples of an embedded system include microcontrollers in household appliances like washing machine, industrial control systems in manufacturing plants, navigation systems in automobiles, and medical devices like pacemakers and insulin pumps. Let's see the types of embedded systems. Embedded systems basically classified into two types. One based on the performance and functional requirements, and the other is based on performance of microcontroller. Let's see the based on performance and functional requirements. It is subdivided into four types. One is real time, network, mobile, and standalone. We all know that real time means it basically depends on the time variations, and network means it is the connections between or transfer message from one signal to another signal, and mobile is daily use case, and standalone is the it is particular system. And based on the performance of microcontroller, there are three types. One is small scale, medium scale, and sophisticated. These are the mainly types of embedded systems. Let's see the components of embedded systems. These components of embedded systems include CPU, sensors, analog to digital converters, digital to analog converters, actuators, input output ports, memories like RAM, ROM, etc. Let's see what is meant by PIC microcontroller. To build this project, we are using PIC 16F577A microcontroller. The specifications of this microcontroller: it is a 40 pins device. It has 5 ports in total. They are port A, port B, port C, port D, and port E. Port A contains 6 pins, and port B contains 8 pins, and port C contains 8 pins. Port D contains 8 pins, and port E contains 3 pins. It supports serial communication, for it has 2 pins for transmission and receiving. It can also support SPI protocol. We have an oscillator frequency range from 4 MHz to 40 MHz. And let's see how the project simulated using these softwares. The softwares are PIC SimLab, MPLab XIDE, XC9 compiler, PIC Genius. In this specifically PIC 116F877A MC board we are using. Let's see what is meant by embedded C. C language is an important for embedded systems due to its efficiency, portability, and low-level access, enabling precise control over hardware and optimal resource utilization. Data types and variables in embedded C uses to understand different data types and variable declarations for efficient memory usage. Pointers and memory management, manipulating memory addresses and accessing hardware registers directly. Control structures, implementing decision making logic and repetitive tasks. Functions and modular programming, encapsulating reusable code blocks and facilitating modular software design. Preprocessor directives, manipulating source code before compilation for defining constants and conditional compilation. And let's see what is meant by peripherals. In peripherals, mainly first one is the LED, which is known as light emitting diode. It is a semiconductor device that emits light when an electric current passes through it. LEDs are commonly used in various applications. LED is an external device connected to microcontroller port. A port is interface between the microcontroller and external peripheral. LEDs are commonly used in various applications including indicators, displays, illumination, and has components in electronic systems due to their efficiency. And the next peripheral is the tactile switch, which is used as a digital keypad. In microcontrollers, switches are often used as inputs to control the operation of the device or to interact with the user. When the button is pressed, the switch turns on, and when the button is released, the switch turns off. They are typically connected to specific input pins on the microcontroller, enabling the detection of switch state and changes. The next peripheral is CLCD, which is known as character liquid crystal display. It is a flat panel display technology that uses liquid crystals to modulate light and display images or text. LCDs operate by modulating light through liquid crystals controlled by electric signals. Important pins for interfacing with an LCD include power, control RS, RW, and E, and data lines like D0 to D7, along with the contrast control pin V0 and backlight pins A and K. Let's see the interrupts. Interrupts in microcontrollers are hardware or software signals that temporarily suspend the normal program execution to handle critical events or external stimuli, and internal or external requests to the MPU to stop the processing. Attends to the request. There are two types are hardware and software. Let's see the another peripheral. It's a timers. Timers in microcontrollers are versatile hardware modules used for measuring time intervals, generating precise timing signals, and implementing time critical operations. They can be configured to operate in various modes, including timer, counter, pulse width modulation, and capture or compare modes, catering to a wide range of timing requirements. Timers often feature adjustable prescalars and revolved values, allowing for fine-grained control over the timing resolution and period, essential for applications such as motor control, communication protocols, and real-time systems. The code is already uploaded to the board, and the board is shown as like this. On the top of the board we can see that washing programs like dry only, wash only, aqua store, etc. As we already uploaded the code, when we press on the washing machine, for pressing on we need to press the key 5. It shows the power on, and programs are daily, heavy, whites, delicates, eco cottons, stain wash, woolen, bed sheets, resin plus dry, and these all are the programs allowed in this washing machine. And if we want to start the only dry wash, then we need to press the key and it shows the levels like auto, low, medium, and high also. Now let's make it to auto, pressing the key, and it shows start. For starting we need to press the key 5, and for the stop we need to press the key 6. Now we are pressing the key 5, and it shows the time like 46 46 minutes. Now it's running the mission, and now if we want to stop that we need to press the key 6. So if we press the key 6 it will stop. Now I press the key 6, so it is stopped. And if we want to restart it we need to press the key 5, and it is restarted. So like this, if we want to do any dry wash, clean wash or anything, we need to operate by these keys only. And once if the function is completed, the system automatically indicates us by a buzzer. Let's see that too. As the time is completed, the it is automatically indicating us, and we can repeat this program again. This is about the project of on washing machine simulator. Thank you.